We are given an array of integers representing the temperatures for each day. Our task is to return a new array of the same size, where each element indicates how many days we need to wait to get a warmer temperature. For example, if we look at the first day, the next warmer temperature is 74, so we only need to wait 1 day. For the second day, it's also just 1 day. However, for the third day, we need to wait 4 days. So on so forth for the other days. If there are no future warmer temperatures, such as on the last 2 days, we simply place a 0. Let's start with a naive solution and then work to improve it. First, we create a result array filled with zeros. Then for each element, we search through the array for the next greater value. Finally, we'll use the indices to calculate the number of days passed by subtracting them. This process is repeated for each day until we obtain the final result. The code will look something like this. However, we can notice that this approach has a quadratic time complexity due to the nested loop that checks each following day for a warmer temperature. So it will likely exceed the time limit on LeetCode. But we can do it better. We'll use another approach to solve it in linear time. Let's bring back our temperatures array along with a result array initialized with zeros. Now, we'll start iterating through the array. For the first day, we haven't found a warmer temperature yet. So let's store it temporarily and move on to the second day. We'll store the second day too. But before doing that, we should check if this day has a warmer temperature than any of the previously saved days. Look at this. We found a warmer temperature for the first day. Using the indices, we can calculate the number of days it took to get warmer by subtracting them as we did before. Now, we no longer need to store the first day, so we'll remove it. Let's store the second day and move to the third element. Once again, we check if the third day's temperature is warmer than any of the stored days. We find that it's warmer for the second day, so we set the result for that day, remove it, and save the third day. We move on to the fourth day. After comparing it with the stored elements, we find no warmer temperature, so we simply add the fourth day to our storage. Moving on to the fifth element, we compare it with the saved element, but still don't find a warmer temperature. So, we'll store it too. By the way, the data structure we're using here is called a monotonic stack. It's a special kind of stack where elements are stored in either increasing or decreasing order. In our case, it's decreasing order. Now, let's go to the sixth day. When comparing it with the stored elements, we notice something interesting. It's a warmer temperature for 2 previous days. We set the results for both the 5th and the 4th days, remove them, and finally save the 6th day. Moving to the 7th day, we compare it against the stored elements and find it's the warmest temperature of all the saved days. So, we set the results for the 6th and 3rd days, delete them, and save the 7th day. Finally, we reach the last day. We compare it, but don't find a match, so we just store it. And that's it. We've finished building our result array. Now, let's move to the coding part. We'll start by creating a result array filled with zeros, which will be returned at the end. Additionally, we'll need a stack. We'll iterate through the temperatures array. For each day, we need to check if the current temperature is a warmer day for any of the previous days stored in the stack. Since we don't know how many elements might match, we'll use a while loop. The conditions for this loop are as follows. First, The stack should not be empty. And second, the current day's temperature should be higher than the temperature at the index at the top of the stack. Notice that we're only storing indices in the stack. If we need the temperature for any day, we can look it up in the temperatures array. If both conditions are met, we'll pop the top element from the stack and update our result array with the number of days that have elapsed since that day. Finally, we push the current day onto the stack. Great! We've completed the code. Now, regarding complexity, the for loop runs n times, and the while loop can execute at most n times by the end of the for loop. Together, this gives us a single linear complexity.